allow me to pull up a website for you. I'm going to go to google.com on Microsoft Edge, and we're simply going to hit enter. You see how fast that was? How in the world does that happen? Behind the scenes, connecting to a website. Welcome back to a new episode of AJ Tech, and today we are going to be diving into the world of networking. That's right, networking. So without further ado, get yourself a beverage. Hang on. Got mine right here. Sit back, take some notes, and let's dive into the basics and understanding how networking works. Let's go. Wonderful world of networking. Let's talk about it. How does a website pull up that fast? Just simply type in a web address. Or if you're playing an online game, the button commands on your controller, how does it respond and reflect to the online game? Answer simply is called networking, or computer networking, if you will. But let's answer the question, what is networking? So, it is a process connecting two or more computer devices, such as a desktop computer or a mobile device, or routers or applications, to enable the transmission and exchange of information and resources. Connection that can be established using either wired or wireless, such as Wi-Fi, to allow devices to communicate and share data effectively. That's networking in a nutshell. So, in other words, how fast it goes anymore these days, it's crazy that a website can just pull up in a second or so. Your action commands on a online game can just reflect so quickly. What all goes on behind the scenes when it comes to networking? That's the mystery. That's the exciting thing about the world of networking, is all how it works, how it all comes together, how it all communicates. So we're just going to go over the basics of this episode, and right over here, of course, is the setup, the home setup for my home network. So you probably have something similar like I do sitting over here, probably not in this ideal location, but this is kind of the central location where I decided to put my home network. Right here first, let's talk about this box right here. This is your modem, what provides your internet service, or internet service provider, also known with the initials ISP, your internet service provider. Whoever that's from, whether it's AT&T, Socket, Spectrum, Cox, whoever it is, that's where it begins. And you got a few cords right here. Of course, that's the power adapter right there that powers it on. You have this one right here. This is fiber optic. So you have a fiber optic cable. This cable actually goes through this wall underneath the crawl space, which I have the cord mounted in the beams, the 4 beams underneath, that goes outside to heck if I know where the rest of the wires go for fiber optic here, but it goes out there somewhere. And that's how I get my internet, is simply through this cord to this box. And then you have this other cable, what is called a Cat6 Ethernet cable. We'll go over Ethernet cable specifications another time, but just know it's an Ethernet cable. So that goes directly into this right here, which I think everybody's familiar with. We all probably have them in our houses, a home router. You can pick these up easily at Walmart, Best Buy, wherever they sell technology. You'll see these sitting there. This is basically a Linksys brand, the EA7300. had dust over that. Couldn't see it. So there you go. But this is the router. This has multi-purposes within this thing. It's a multi-layer device. We'll talk about layers here in a little bit. But it's a multi-layer device. So what it does is it acts as a switch, a router, has a built-in firewall as well, and an access point. There's 4 jobs. That's what this thing does. It does 4 jobs. So basically, this thing is here. Ethernet plug is plugged into the port that says for internet purposes. That gives you the internet access. Most of you guys probably stop with Wi-Fi, right? A lot of you guys just utilize just only Wi-Fi in your home, and that's how you operate your internet, is strictly off of Wi-Fi services. And it's really all you probably may need. You may not have any devices like a computer or TV hardwired with Ethernet cabling such as this right here plugged into the back. You're probably just basically using a Wi-Fi service. The access points, which is basically these antennas right here. That's what provides the over-the-air Wi-Fi frequencies. Your home router can come in different varieties depending on what you pick up. You'll definitely want to know the square footage of your house. Buy one that's close or greater than your square footage. You'll definitely want to probably get a dual band one like I do. I have one that has 5 gigahertz and 2.5 gigahertz, which basically same username and password on both. So that way, if devices fall off to 5, it goes to the 2.5 gigahertz. That's how I have mine operating right there for the home usage. Or you can split them up actually if you just want to split it that way. It's up to you. But just know the 5 gigahertz range is a lot smaller, while the 2.5 gigahertz range is a wider range. That's how it's set up. It's a wider range. This thing here covers the entire house. So no need for any extenders or meshes to add in to help boost that signal throughout the house. And also you want to look at the specifications on how many devices can you put on this router. Because the more devices, the more frequencies that it's going to eat up and may cause some lag and slow down if you have too many devices going on with your internet connection. But if you're like me, you're going to want to hardwire your stuff. And honestly, it's more reliable. Direct connection is the way to go for your desktop computers, for your TVs, and so forth, especially for gaming. Direct connection is the way to go for that. So again, on the back of this device, you'll have some additional ports for that purpose, which is basically what is the built-in switch. Or if you want, you can have a separate one right here like I have here. This is basically a managed switch device that is plugged in directly to the back of this, utilizing one of the additional ports to be able to use this functionality to have additional ports right there. And a managed switch, basically what that means is you have control over the ports itself, creating different types of VLANs, turning them on or off, etc. So with the hardware out of the way, how does this work? All right, ladies and gentlemen, we're bringing it back over here to the computer, and we're going to kind of dive into how networking works. I want to introduce you all to what is known as the 7 layers of the OSI model, or per Wikipedia, Open Systems Interconnection. Now, this isn't really used today anymore in the world of networking, but it's really more in depth of what is used today. Today they use what is known as the TCP/IP model, and basically what they do with that, they basically take application, presentation, and session and lump them together as layer 5 application layer. I have seen some where they lump these here together, but I like to keep these separate, to be quite honest, because it makes it more understandable for me. Because the physical, you're looking at the physical structure, like your server towers, these are like old, like hubs. You mean switches. Hubs are like ancient technology anymore today. Nobody really uses them. It's now switches. Or Ethernet cabling, which that's not listed here. No, it's right here actually. Data link, Ethernet. Okay, cool. But the cabling, it's a physical thing right there. It should be physically there listed. Whatever. But anyways, let's go through this real quick. So just like how, pulling up a website, for example, you start with the application layer. We're going to just close all this out here. And I'm just going to reopen up a new web browser. So pulling up Edge, boom, instantly this is my default page, msn.com. But if you type in, say, www. We can use CBT Nuggets. That's what I use to do my training and stuff here. CBTnuggets.com. You can pull this up. Look how fast that pulls up. Everything happened in a split second, and it just pulls up. But I do highly recommend, if you are interested in getting certifications and such, CBT Nuggets is the site to go. Thankfully, my company pays for the licenses, so I get the training, so it's nice to have. But maybe your company will do the same, who knows? Or, you can check it out for yourself if you're willing to spend. It's a lot cheaper than college, a lot cheaper to get degrees. Highly recommend it. It's an annual subscription. Get labs, get test and practice exams, all the video trainings you need to go through and get your certifications in whatever IT field you want to get. If you're starting out, CompTIA A+ is the one to go with. Of course, I think they're revamping that here within the next 6 months, so get it in now if you want to get it in now. Otherwise, you're changing the exam and they're going to have a whole new training on that. So anyways, but yeah, as we can see, it pulls up really fast right here. So a lot of things happen behind the scenes right here. And then this is the application layer. This is layer 5. It's your web browser. You type in the web address. So let me show you something else too to kind of really home it in. They use IP addresses. So I'm going to pull up the command prompt and I'm going to do ping cbtnuggets.com. And looky there right there. So I'm pinging it, request timed out. What the frick? Not a good example, really. All right, so we're going to use google.com instead. So we're going to use ping www.google.com. And right there's the IP address right there for google.com. As you can see, it's right there. So I typed in the web address to ping the site. It pulls it up as this right here. And you get the replies transmitting the packet to there. They reply back to you. So you have a connection. CBT, what's wrong with you? Why couldn't I get why'd you time out on me? That's weird. Maybe I need to include the www. cbtnuggets.com. It's not recognized. Oh, maybe I don't know. Oh, you know what? Ping. I forgot to do that. We'll get back to the model here in a second. Nuggets.com. Okay, there he goes. You need the www in there. Don't just do the. Yeah, there you go. So now it's responding. But that's pretty much what it does. It's, you ping it, it'll send a packet to the site. The site will acknowledge that packet and will reply back to you. Boom, done. It's really how it works in a nutshell in the behind the scenes. We could use software like Wireshark that will trace the packets, and you'll see everything flowing behind the scenes using the software like Wireshark. We'll do that another day to just kind of demonstrate that. I'm not going to go in depth with that right here on this video. But going back to this model here. So in a nutshell, that's how it works. You start with the application layer. So just imagine all three of these combined together. And then it goes down to the transport layer, which is known as layer 4. And that's where I'll use the transport protocol ports. So for like websites, HTTP uses what is known as port 80. HTTPS, which is the secure port 443. So it's sending the data through those ports, depending on which one it goes through. And that's how it's going to send it out. So you go from your website application layer, you're requesting google.com, it'll send it out to the transport layer and shoots it out over the internet to their network, which lands in their IP address, the router. Okay, layer 4 is your network layer. Oh, sorry, layer 3, my bad. Your layer 3. I had to look at my transport layers here. Holy cow. Layer 3 is your network, all right? That's where your router comes into play. It uses IP addresses to identify on where to route things to. Then it goes down to the data link layer, which is basically your switch. Layer 2, that's your switches. So those ports on the back of your home router that you hardwire your stuff in, that's a layer 2 function. That's a layer 2 switch that's built in. So it'll send that down through there using the built-in MAC address. Your machine has a MAC address, and it's permanent. It doesn't change or nothing. It's what has been basically burned into the system, so to speak. So it'll send it to that particular device using the MAC address, which goes to the physical device. So in the case of requesting google.com or youtube.com, it sends it all the way down to their server. And then what happens, actually before it gets there, there has to be what is known as a TCP three-way handshake. The TCP three-way handshake is a fundamental process used in the transmission control protocol layer 4. So that's this right here. So that's where the acknowledgement happens. That's where it takes place, is at layer 4, to establish a reliable connection between a client and a server before data is transmitted over. All right. The handshake ensures that both parties are synchronized and ready for communication. So basically, networking is really communication. It's one device talking to another device and requesting information, requesting data, requesting files, requesting a website in this case. So it basically does these 3 steps, what is called synchronization. Step 1, the client, which is you, initiates the connection by sending a segment with a synchronized flag set. The segment informs the server that the client wants to start communication and includes the initial sequence number. All right. Then next thing you go to step 2, the synchronization acknowledge or synchronize acknowledge. The server responds to the client's request. So that's where google.com or youtube.com responds to you. All right. You, the client, requests with the segment that has both the sync and the ACK flag set. The ACK sounds like Mars Attacks. ACK. All right, there you go. The ACK flag acknowledges the client's synchronized segments. I'm done saying ACK. It's just too funny. And the synchronized flag indicates the server's initial sequence number. ACK. All right, one more. Acknowledgement. This client sends the acknowledgement segment back to the server, acknowledging the server's sync acknowledgement segment. This completes the handshake. So there you go. It's basically you just walking up to google.com and saying, hey, I would like to access your resources. Google thinks about it, it's like, okay, yeah, that sounds all right. Here's the resources, and you get the resources. That's pretty much what happens. It's basically you greet them, say, hey, how are you? Can I use your resources? Absolutely. You can use my resources. Here you go. And that's how it works. It's communication 101. That's all networking really is in a nutshell. Is basically you take devices and you make them talk to one another using basically MAC addresses, IP addresses, creating that synchronization, the connection, and allowing them through. So there is a firewall. I forgot to mention about firewalls in this video here, but they do play a role. And also forgot to mention about default gateways. Routers utilizes a default gateway, which basically is the entryway to your network, to your machine. And the firewall layer basically is what helps allows or not allows into your home network, which helps with preventing any possible attacks and such. So that's pretty much that in a nutshell. So your home router has a built-in firewall. I'm having troubles right now. Firewall. Your computer has firewall capabilities as well. And anymore these days, your Windows computer especially with Windows 11, you have what's known as Windows Defender. It has antivirus, it has firewall, defending capabilities. It's all built in. Throw away those softwares for antiviruses. Throw them away. Use what's built into your machine. It has enough security for protecting you online. And make sure you run your updates. Check for updates. Get the latest updates for security. Heads up, Windows 10 users, your time's come to an end. October this year. You want to consider making the switch to Windows 11 because they ain't going to support it no more with 10. With that being said, thank you guys so much for watching. To the basic introductory of networking. With that being said, thank you guys so much for watching. Stay safe out there and take care. Don't forget to like, comment, and subscribe.